Hi Year 13s. In this video we're looking at polynomials, which you'll be pretty familiar with from Year 11 and 12 maths. In particular we're going to look at the way we can divide polynomials. So there's a bit of a definition there, and you can read that in your own time, but I'm going to jump straight into an example. And this example here is asking us to divide this polynomial by x plus 3. And the way we're going to do this is long division. So some of you may have done long division when you're in primary school. And we're going to apply that same method here because in essence, if we're thinking as x as 10, for instance, then this would be our ones column, then this would be our tens column, then this would be a hundreds column because 10 squared is 100, thousands, and 10,000s. And so effectively long division works exactly the same because normal division is based on powers of 10 and this division will be based on powers of x. So that's just sort of an intro, but we're going to set it out exactly the same way. So we'll start by writing x to the 4 minus 3x to the 3 plus 2x squared plus x minus 4. And we're going to divide all of that by x plus 3. Now it has slight differences between long division, and one of the differences is we only divide the leading coefficient. So when we're when we do our first division, we're saying how many times does x fit into x to the 4, or another way of thinking of it is what's x to the 4 divided by x, and x to the 4 divided by x is x to the 3. So that's the first thing that we put up there. Okay, what we do now is we times that back with both of our terms of what we're dividing by, and that gives us our remainder, and so we get x to the power of 3, to the power of 4 minus 3x cubed. So x to the power of 3 times x gives us x to the 4, and x to the power of 3 times 3 gives us x to the power of 3, and that should be plus, not minus there. Okay, so that's our first term. So what we'll do is we subtract our terms here. So x4 minus x4 is 0. Negative 3x minus 3x cubed will be negative 6x cubed, and now we're dividing our term into this term here, and that's going to give us negative 6x squared, and then we times that back with both of these to get our term underneath. So that's going to be negative 6x cubed minus 18x squared. And we also drop down that 2x squared down to here so that we've got an x squared term to subtract from. So now we subtract these terms. So our negative 6x cubed terms subtract to 0. And then these two terms, we've got 2x squared minus negative. So if I wrote that out, it would be 2x squared minus negative 18x squared, because we're always minusing the term underneath, and so when you've got two negatives like that, that's adding them, so you're going to have 20x squared, and now we're going x into 20x squared, and so x goes into 20x squared 20 times, so we've got plus 20x there, and we multiply that back with the other two terms. Okay, so that gives us 20x squared plus 60x, and we'll bring down this x here, so we've got plus x, and now we'll subtract again, so we get negative 59x, and we'll divide into that, so we get minus 59, and then times back, so we've got minus 59x minus 59 times 3, so that's going to be 180 minus 3, so that's 177, and then we'll bring down the negative 4, so we've got minus 4, Then we subtract these terms, and so negative 4 minus negative 177 will be positive 177. Now you just notice here that we've got no more terms to divide into, and so this number that we have left over here, this is our remainder, and so we'll write that there, R for remainder. And so what that means is when we're dividing these two polynomials together, we end up with that remainder there as well. Okay, so we can say that I'll write it out in full again. X to the 4 minus 3x cubed plus 2x squared plus x minus 4, that when we divide it by x plus 3, we can write it as x cubed minus 6x squared plus 20x minus 59, and then we've also got that remainder there, so we say plus a remainder of 177 divided by x plus 3, because we're still dividing by x plus 3, but we can't go any simpler than that. Alright, so that's an example of using long division to divide polynomials, and lots of reasons for doing this. One is for differentiation. Sometimes we may want to do it for that, but really it's that whole idea of algebra where there's often reasons for having terms in one form rather than another, and in this case this is just another way of writing these terms in a different way. So I'll finish the video here, and then in my next video I'll go on with the next example.